So, electronics hardware design itself has got multiple disciplines. You need to design these analog circuits, okay, digital circuits, and you need to design antennas. You need to design, you need to take care of the cables, all that. So hardware design itself is basically a very complex area. And in hardware design, defense electronics or defense grade hardware design is further complicated because of the very obvious reasons. But due to a vast experience that is put up in the company, we are in a position today being able to supply the military grade hardware to the users. Okay, this capability is only limited to government R&D labs and like big production agencies like Bharat Electronics. At private industry, it is available in a very limited number of companies in India. Okay, so go next. So this is, all of you know, electronic hardware design, circuit design will be there, and you make a breadboard prototype or maybe some temporary soldering prototype, then you do PCB design and all that. Maybe I'll not dwell much on this. Okay, go to next. Yeah, right from the component choice, and the component selection, you need to be very careful, because every component and every material that you are selecting should meet the final military grade requirements. It may be temperature, it may be vibration capability, or it may be humidity, humidity or other things that they want to do. So in any military grade component, you have to select and you have to ensure you design the footprint, you design the PCB as per that. And one more challenge in the military is obsolescence management. It means one IC, suddenly it goes out of the market. You have to newly design. So these are the essential things that one company need to know. Otherwise, you won't be able to serve the defense products. The reason is, in defense, our users will ask minimum 20 years of product maintenance support. So 20 years you must be able to support the product. I think you guys have seen what will change in 20 years. Okay, mobile revolution, so many chips will change, FPGAs will change and all, but you need to still support it. So that is additional complexity in the defense electronics. Yeah, go next. Yeah, so this is again same illustration about different component. Now, see, we train the people who join our company in hardware very narrow into areas. For example, if somebody joins as electronic component analyst, their job is only component level analysis. So if you just take one diode, like all this goes to your early days courses that you have done, the electronic circuits, electronic devices and all. If you take a simple diode, you know what are the things, what are the characteristics that you have to take care. So based upon the choice of the design, you must know how to pick it. And this must be extremely, conceptually correct choice you have to make. So that is where we try. So in our hardware design also, we have multiple roles: electronic component analyst. Okay, front-end design in the hardware means it is a schematic and all, circuit design, schematic design. Back-end design means PCB routing, like that. Yeah, go next. Okay, a typical PCB design, how it is done, I think all you guys are aware of. Okay, there are 3 important cycles. Manufacturing we don't do, because PCB manufacturing is a chemical intensive process. So there are companies in Bangalore who we outsource our design to them. Yeah, go next. Now the challenge in the PCB design, or the challenge mainly in the hardware design lies, how do I put it? Maybe I can tell. I think some of you people have completed the course, this transmission lines, waveguides and transmission lines and all. And there is one more coursework that you must have done, network theory, where you learn about these S parameters and all. So in the entire PCB design, the challenge lies in doing this impedance matching, handling the parasitics like capacitance, inductance, coming up with the tracks, 2 tracks going parallel, it will automatically create a capacitance. So impedance matching are the challenges. So the backend designer of the PCB design. So there we will train on these aspects. Okay. In industry, there is a popular word, probably you don't come across at the undergraduate level, signal integrity analysis. It's called SI analysis. So signal integrity is exactly this. The subject basics are same what you studied. Okay. Yeah, go next. So this is another example case study of the FPGA board that we have developed in our company. It's a 14-layer board. So in each layer that there are different components, you know, each different type of routings that we do. Yeah, go next. Okay, now our plan is in the research, in the 2 weeks training program, we want to give open source kind of softwares. So this software for the PCB design we will be using in our 2 weeks training program, you know, for the electronics, defense electronics lab. Means if the people are opting towards the electronics lab, then we would be taking up this. Yeah. Next. So, you know, these are the different stages in the, what you call circuit design or schematic design. Yeah, go next. And these are the different stages in the layout backend. So, you know, you do footprints, you do routing, all this. Yeah, go next. So next you have a different type of, so these are all to tell the complexity in multi-layer PCBs that you will be using, that whatever you are seeing in the screen, there are 4 layers are there. So in your design, depending upon the interconnectivity, you will use one of this kind of interconnectivity. So all this you will learn during the 2 weeks training program and followed by 90 days of research internship. Yeah, next. Yeah, these are also continuation of the previous. You can skip this and go next. Okay, now testing is a very crucial thing in the hardware. It's not that easy. That in fact, the more talented people who join in the company, we will put them as a testing in the testing part, test and validation part. We call them as test and validation engineer. It is not an easy thing because the amount of instruments knowledge that you need for testing and the background knowledge to understand the user specification and applying them and using instruments and doing is really challenging. That you will use multimeters, oscilloscopes, spectrum analyzers, network analyzers. Network analyzer is nothing but the S parameter measurement tool kind of thing. Okay, all this, right? So in the R&D center, if we are opening up an R&D center in the defense electronics, this kind of instruments will be kept so that you will use them and you will learn on them before joining in the company itself. You learn all of them. Now, next challenging area in defense electronics is integration. You know, as I shown in the previous slide, these equipment are very complicated equipment and they have to, like for example, drone detection system has to work up to 5 kilometers. And some products, you know, they need to work up to 10 kilometers. So you will have a lot of antennas, okay, lot of antennas and, you know, a lot of electronic hardware and all. How do you package them? How do you package them such that they withstand the required vibration, they withstand the required temperature variations and all, is itself a very challenging thing. So we have a separate role in the company called integration engineer. And the integration engineer will have a bit of what is it called, mechanical wise understanding also. He knows what issues of mechanical, what issues of electronics are actually he need to, what is it called, put together to build a system. So the image that is being shown here is something like in the video, in the RF detection system, a big dome kind of thing you have seen. So it's a bottom side, and whatever has been shown one step is how you stack electronics into that. Is one example it is being shown. Yeah, what is next? Go to next. Now, these are the further videos, further images inside that, what kind of electronics is that. So we know that these are all defense products are confidential. So we are showing some certain data which is not confidential. Okay, like that. Yeah, go next. So this is something like another inside electronics of it. Yeah, go next. So this is one more image which is showing a typical RF PCB. See, the point is, as I mentioned, our company is into expertise of not only designing the digital, Analog and RF. RF you mean high frequency electronics, like up to X band, Q band, going up to 18 gigahertz and all. So there the design principles will be different. I mean, the fundamentals are still same, but you need to more worry about electromagnetic interferences, electromagnetic coupling effects that you get. And you need to more worry about this impedance mismatch kind of challenges and all. So this is the RF PCB, how we design. Yeah, go next. Yeah, the total RF PCB design is around the S parameters. So I think you studied these S parameters as a part of your coursework. Next. So this is a typical screenshot in an instrument. When you see S parameters, how do you measure S parameters? How do you use? So the 4 S parameters you measure, and they must match your design expectations. Yeah, go next. Yes, this is what is the most challenging thing called impedance matching. So whenever you are designing an RF circuit, could it be amplifier or attenuator, you will take care of the impedance matching in the final stage of your soldering, and you will tune the circuit by tuning capacitor or tuning inductor and achieve necessary impedance matching. Yeah, go next. So you all guys know the Smith chart and all, right? Okay, the Smith chart where you use for, if the output port impedance of a circuit is something like 2 plus J3, you have to give the input impedance of the load 2 minus J3 so that the maximum power transfer takes care. So this you guys know. So this need to be done at every stage, okay, in the RF design, in the RF integration, like that. Yeah, go next. Yes, as I mentioned, the electromagnetic interference is a key thing, okay, in the high frequency PCB designs, high frequency circuits. Like most of you must have seen, most of you must have seen that whenever your phone is beside a TV or maybe radio, when the phone rings, you get a disturbance voice in that. That is electromagnetic coupling effects, what you get. This is not possible in military, because in military, like you have seen in the animation, the product animation, whatever our vehicle-based anti-drone system, wherever you have the rack, and in the rack you have those electronics. So you will have our friendly radio and you will have a jammer side by side. Okay. So our friendly radio should not get interfere with the jammer. The jammer purpose is to jam the enemy radios. Got it? So electromagnetic interference effects are very important right from PCB till the product comes to enclosure level. What is enclosure level? I'll show in the next slide. Go next. Yeah, I mean, this is one more precautionary step. Your PCB, whatever the printed circuit board, uses a lot of copper layers and all like that. This will easily catch corrosion because the systems that we deliver, they may go inside a deep ocean, like maybe in the inside the ship, they may go 1,000 kilometers deep into Indian Ocean and all. There, not just like that, things get into corrosion because it is all humidity levels are very high, like that. So you do some special steps called conformal coating and all. So during the 2 weeks training program, so there will be a virtual something like an industry tour showing these things in our office, how they work. Okay. For the students in Hyderabad, we are planning to show physically. Maybe we can invite you physically or we can give a virtual tour. Now this video is an example. It is showing when you want to give a product to defense, they just don't take like it. What they do, they know typical one aircraft vibration. They know typically one ship vibration. They know typically one vehicle, because these army vehicles, whatever, they go through terrains, mountain terrains and all. There are no roads there. Okay. So they do some vibration. Just this video is showing one typical vibration test. So actually, the vibration is so fine that it is not that easily seen, but they load through software the vibration profile of a particular standard. Once you meet the standard, then the product meets, product is acceptable for vehicle integration. Otherwise, it is not acceptable. It's like that. This test facility is given, I mean, they do 4 hours test, 8 hours test. There are some tests where they do 3 days continuously. They call it as a thermal cycling. So thermal cycling is a test where they take the temperature down from minus 30 to plus 50. They do very fast. Like suddenly the system is taking a thermal shock. Whether the system is still working or will there be a problem, something like that. Yeah, you can go to next slide. Yeah, I think this video we have seen. You can go to next slide.